In this worked example, we're working very diligently through a calculation that requires us to determine the value of n here. So you can read through the question on your own time. We're just going to, sort of just jump right in here. We know that the left side here has no units because it says C sub d is a number with no units. And so we have to make everything sort of cancel out on the right side here. So I've got newtons of force in the numerator. I've got meters per second to some power, and I'm putting the seconds back up here in the numerator. Got density, and so that's going to be a kilogram per cubic meter. And I got area, so that's going to be meters squared down there. All right, so let's get rid of those. So that meter is there. That meter is going to cancel that one actually. And so I have a newton, which is a kilogram meter per second squared. And so that's going to cancel those. And so I end up with well, actually, so meter to what power? So I still need to cancel out that meter. And I got to cancel out two of those. I must have went wrong somewhere. Let's try it again. So force is a newton, which is a kilogram meter per second squared. There's my newton. My velocity is meters per second, and I have to raise that to some power. My density is kilogram per cubic meter, and then my area is meters squared. All right. So I've got meters to the fourth and meters squared down here. I think I lost track of that meter. So those two go away. I got meters squared. Kilograms cancel. And so this has to be a 2, right? So that will cancel out those meters squared. That's a 2, cancel out those seconds squared. So n has to be 2 in order to cancel out everything so that we're dimensionless on both sides.